All right, in this section, we're going to talk about exponential functions of the form f of x is equal to b to the x power. So an exponential function is a function where you have a base raised to an x power. And here is an example of what an exponential function will look like. Okay, so we're going to go through each of the characteristics. So whenever you have an exponential function where where x is the exponent, the domain of this exponential function consists of all real numbers from negative infinity to positive infinity. The range would be from 0 to positive infinity. Now, this can change depending on how the exponential function is formatted, and then your range will be somewhat different, but the domain will always be from negative infinity to positive infinity. Now, what's going to be consistent whenever you graph an exponential function is that the graphs are going to pass through a certain point, and it's going to pass through 0, 1. It says because whenever we find f of 0, we're going to get b to the 0 power, which is 1. There will be a y-intercept, which is at 0, 1, but there will never be an x-intercept. For number 3, it says here, if your b, meaning our base here, is greater than 1, it has a graph that goes to the right and is an increasing function. The greater the value of b, the steeper the increase. So this example here, where I'm pointing to, is a graph where our base b is greater than 1. But if our base b is between 0 and 1, it has a graph that goes down to the right and is a decreasing function. The smaller the value of b, the steeper the decrease. So this here is our what happens when our base b is between 0 and 1. That's number 4. Number 5, f of x is equal to b to the x is 1 to 1 and has an inverse that is a function. So 1 to 1, we pass the vertical line test. Only 1 point touches the line. And also the horizontal line test, um, only 1 point touches the line. And then lastly, the graph of f of x equal to b to the x power approaches but does not touch the x-axis, which is called the horizontal asymptote, i.e. it has the equation of y is equal to 0. So we're going to look at some of these graphs here, but always understand that what's going to be consistent whenever you have the form of f of x is equal to b to the x power, what's going to be consistent always is that you're going to have a y-intercept at 1, and that point is at 0, 1. Now what we'll have to look at is, okay, will the graph go to the right? Okay, will it increase or will it decrease going to the right? Okay, goes up to the right or down to the right. But will it decrease or will it increase? Will the function increase or will it function decrease? Okay, so and then with these type of equations, f of x equals to b to the x, you will have a horizontal asymptote at y equals to 0.